Here's number 3 on the bottom of the back of the orange sheet in the net force section. How much force is needed to accelerate a 20 Newton stone upward at 5 meters per second squared? So I'm looking for the amount of force that needs to be applied. 20 Newton stone, when it's used as an adjective like that, that's telling you the weight. So I know that my weight is 20 newtons. Here's my free body diagram. I have a stone, and I'll have two forces acting on it. One is the weight, and that's the earth pulling it down, always goes down. And the other is your hand that is pushing on the stone in order to accelerate it upwards. And since I know that my acceleration needs to be a positive 5 meters per second squared, that means that it's going to be unbalanced in the up direction. So this one pushing up is going to need to not only overcome the weight, but then give it some more to actually make it accelerate upwards. Alright, FA, this is what I'm looking for. Alright, so I have my free body diagram. I've got the weight since it's a vertical problem, but I'm also going to need the mass. Now this is a side piece. This has nothing to do with some of the forces in an MA. It doesn't have anything to do with the 5. This is just a separate section where I use FW equals mg. I'm either multiplying or dividing by 9.8. So I would have 20 equals m times 9.8 and divide, and I get 2.04 kilograms. Alright, I have my mass, my weight, I have my free body diagram. I'm ready to sum the forces and set it equal to m times a. Again, in this case, I only have two forces. I have the force applied that's going to throw it up, minus the weight, because it's pointing down. And then fill in your numbers. I don't know what FA is. Minus the weight equals the mass times 5. And that is the actual acceleration that is happening to the rock. It's not 9.8 because it is not a projectile problem. So I get 10.2 on this side, FA minus 20. If the question said what is the net force, remember the net force is equal to either half of this equation. So right here I would be able to tell you that the net force is 10.2. That's the unbalancedness that's going to cause this rock to accelerate at 5. And FA is equal to 30.2 newtons. See how if this is 30.2 newtons up and the 20 newtons down, the net force is that 10.2.